over on the shark bite. It looks like majority 4s and then some 3s and 2s. So we'll do those 3. So all of this can be done in Desmos. So starting with number 2, you could either, I think last time I just put it in as parentheses. This time I'll put it in as capital X. And then I'm going to add in the slider and change this to -1/2. Sorry. So then with all the x's, this would be -0.5. So that would be your answer. If you're using this, make sure you use Desmos. For number 3, if I put in the ordered pairs, I can see that they fall on the same vertical line, so the slope of that would be undefined. And then for number 4, finding the line of best fit, you could do that in the calculator or in Desmos. Make a table, add in all of those points. And then type in your y1, the squiggly line tilde, mx1 plus b. And our line of best fit would be y equals, let's do 3 decimals, 0.847, x minus 10.640. Questions on any of those? On to the SOL packet. Make sure you have these written down. That way you can go back and practice it at a later time. 7E, you were given domain values, x values, and you had to find the range values. So you had to put each one in for x and find what y was, which was 82 and then 325. SOL 8 was all of your direct and inverse variation. So if you remember what your inverse variation looked like, to find k, you're multiplying the two variables. the equation itself is k over x usually, but this one has different variables. So you could eliminate a and c, and then the one that looked like one of those two was b. You'd have to find your k value. And then using that equation, I could find when x or w is 60, and that would be about 2 days. Number 2 was direct. So you had to remember those equations. Y equals kx, or in this case, using your variables, finding k is y over x, and b was your correct answer there. Number 3, you have to look for ordered pairs. Sorry, 2 ordered pairs that would be direct. So if you found your y over x from the given one, and then try that for the others, there were only 2 that worked, the ends. Or if you put those into Desmos and saw which ones were on the same line, that would also give you your answer. And on to the next page. Part 4 was just asking which of these equations were direct, which was 1/5 x, negative 0.5x, and 3x. All the other ones were either inverse or not at all. The graph of the direct variation is the line that goes through the origin. Same thing for 6, the line that goes through the origin. And then for 7, part A, you had to find 3 points that would make it direct. So if you did y over x, there were 3 that worked, 4, 16, 3, 12, and negative 2, negative 8. And then on to the next page. Part B was finding the inverse. I just re-put the points up there. You don't need to put that. But the 3 that were inverse were negative 4, 3, negative 6, 2, and negative 1, 12. Make sure you do have that. 8 was similar, finding which 3 were direct, and that was 3.57, 4, 8, and 8, 16. 9 and 10, you just had to plot points that would make it a direct variation. So for 9, you can put any 2 points. You can put all of them and write any 2, or you could just put 2 of those points. 10 was the same thing, but you had to pick 3 points. So you can draw all of them and write any 3, or just pick 3 points. 11 was the beginning of a question, but it didn't actually ask the question until 12, so just skip to 12 on the next page. And then you had to find, was this direct or inverse? If you multiplied them or put it into Desmos, you would see it's inverse. Hold on. Okay, and then if you multiply them, you saw you got the same number, and you would need the inverse variation, which was all of SL9 was either line of best fit or quadratic curve of best fit. The curve part we haven't talked about yet. We're just going to do that next week. So I didn't count some of those, but some of them you should have been able to do. So for number 1, if you put these into Desmos and match them to this, there was only one that matched it exactly, which was D. For 2, that was your line of best fit, finding your output when the input was 5, so B. For number 3, you would have to know your quadratic curve of best fit, so if you didn't get this one, it was okay. But after using that, you're finding the y value when x is negative 4, which would be about 2.33. Go on to the next page. Number 4a was, again, quadratic curve with best fit. So if you didn't know that equation, that was okay, but make sure you have this now, write it down. Y equals 3x squared plus 2x minus 8. And then if you were using that, you could do one of two things. Put in x equals 8, look for where they cross, or put 8 into all the x's and find what that answer is, which was 200. And then for part 5, you should have been able to do this. You know it's going to be something that's curved because of the parabola shape. So it couldn't be A or B, and then it's facing down, so it has to be B. Six was another quadratic curve with best fit, so you needed this equation, y equals 2x squared plus 77x plus 50. And then, again, either put it in Desmos or put 13 in to get $13.89. And then the last one on the next page. The last one was finding your line of best fit. You had to change your years from 0 to whatever, how many years has it been, and then using that number, it would be 463 feet. So hold on to this, go back and practice in it, practice Desmos things in it. Come see me with any questions you have. On Thursday, I'm going to give you another one that will be starting to check weekly starting next week. So we'll talk more about that one. Okay, so you should have these notes. Last class we talked about how to graph quadratics. Today we're going to talk about how to graph exponential functions and do some of the characteristics. So this should be an exponential function. Is a function written in the form y equals a times b raised to the x power. So in this, a and b are some real number. They're real numbers. Where a does not equal 0, because then it would just be 0, and that would be a vertical line. B is greater than 0, it's positive, and b does not equal 1. Here are some different examples. So in this, I'm giving you the x's, and I'm giving you how that would look in your table. But moving forward, after we get through a lot of these, you'll have to fill out your x's and then find your y's, either in the calculator or by hand. So we'll do these by hand, and then later I'll show you in the calculator. So for this, I have these x's, I'm putting it in where x goes. So then I have these, and I have to think back to my negative exponent rules. I take my base, I flip it, I make the exponent positive. So then what would this be? What would this y value be? 190. What would 3 to the negative 1 be? 1/3. Anything to the 0 power is what? 1. 3 to the first would be what? 3. And 3 squared is 9. So in all of your exponential functions, you'll see some pattern of either multiplying by some number or dividing by some number. What is being multiplied here? 3. Each time it's multiplying by 3. So you keep doing that and you'll get something exponentially big. So graph those to the best of your ability. Those two kind of guesstimate where they would be. So you'll see it makes this curve like a L, but not a sharp. And it'll look something like that. So I'm going to show you what this looks like on a graph, on your calculator graph and Desmos to show you the difference. And we'll talk about the characteristics in a second. So in this, I see that this looks like it's going to maybe cross the x-axis, but it actually doesn't. In Algebra 2, you'll learn about asymptotes and what that's called and how that works and how to find it. But it's a line that it gets really, really close to, but it never actually touches or crosses. So in the calculator, I'm going to put in 3 to the x and y equals. And then I'm going to graph it. And it looks like it's on the x-axis. But if you go into the table and you start going backwards, you see that we're in scientific notation, there's so many zeros in front of whatever the decimal is, it's never actually at 0. It's just getting really, really, really small. On Desmos, again, it looks like it's on the x-axis, but as I start to zoom in towards the x-axis, I see that it's not actually touching it. And it's going to do that forever and ever in that direction. And you could go and do that and see how far it does that in your own time. So now that we know what the graph looks like, now we can find our characteristics. What would the y-intercept of this be? 1. We're going to write it as order pair, 0, 1. So you either look at the graph or look at the table to find that. We talked about domain and range for quadratics. It's going to be the same here. Domain is your x values, left to right. Range is your y values, lowest to highest. So for domain, what's your furthest point to the left? Negative infinity. And what's your furthest point to the right? Positive infinity, correct. And just as a reminder, you might see this in set builder notation. And that's what that would look like. X such that x is an element of all real numbers. You don't have to write that, but you have to know what it looks like. And then our range, our lowest value is actually going to be here. It's never going to cross this line. So that would be where we start. And because it's never going to actually touch it, it's not included. So that would be parentheses 0. What's our highest point? Positive infinity. Or in set builder notation, y such that y is greater than 0. Okay. This next part is really to see, can you approximate this from the graph from the table, but then actually figure it out as well. So if I had 0.7, that would be like about right there. My graph is not accurately drawn because my points might be a little off. But if I had to guess, I would say like 2.1. Anyone else want to take a guess as to what that might be? I know it would have to be in between 1 and 3 because 0.7 falls within this. Go ahead and put 3 to the 0.7 in your calculator, see what it actually is. So put in 3, raise it to the 0.07. Use this. Bring up those decimals.
2.157669.
Okay, that's good. Sure. So I was close. And you don't have to guess. It's just kind of fun, like a fun little game to guess if you can guess it right before you actually find it. Do you have any questions on how we graph or find the characteristics of this? Let's skip to number 3. Doing the same process, but now our base is a fraction. 1/3 to the negative second power. Take the base, flip it, and make your exponent positive. What would that give us? 9. 1/3 to the negative 1. What would that give us? Take that base and flip it, make the exponent positive. What would that be? Three. Anything to the 0 would be 1. 1/3 to the first power would be 1/3, and 1/3 to the second power would be 1/9. What's that pattern? What are we doing each time? How did 9 become 3? How did 3 become 1? And so on and so forth. What are we doing each time? Divided by 3. So you have to be able to recognize these patterns to know that it's an exponential function. Go ahead and graph those points. What's different between this one and the first one we did? Or does it look the same? Yeah. So instead of it going from left to right, now it's still doing that, but the opposite direction. What would the y-intercept of this one be? 1, 0, 1. What would the domain of this be? Our range, where would that start? If you can answer where this starts. What's our lowest y value?
1.
It's not 1. It's not 1/9. It's going to be lower than that. Think about where all of these are getting really, really close to this y value. 0. Yes, go to the right one. And then what's our highest point? Do you guys want to guess where this might be? What this might be? If this was accurately drawn, I'm saying like right there. Maybe. My graph could be off. Or you guys can put it in the calculator and tell me what that is. Sophia, what did you get? I'm still gonna flip it first. You just put this all together. So I was probably going to guess about 5-ish, so that would have been close. Questions so far? Now we're going to add in some different things and see what happens when we change our A value or change our B value to different things. So go to number 6. And then let's do the same thing, but now we have a negative out front. So we're thinking 1/2 to the negative second power. Take that base and flip it, make the exponent positive. And then after you figure out what that is, multiply it by a -1. What would that give us? Negative 25. What about -1/5 to the negative first? -5. 0, nope, -1/5 to the 0 power. It would be -1 instead of +1. -1/5 to the first power. And -1/5 to the second power. Correct. So go ahead and grab as many points as you can. So I can see that it flipped again, but now it's underneath the x-axis, yes. What would the y-intercept be? Daniel, what would this y-intercept be? 0, -1. What would the domain of this be? Where does this start? Where does it end? Looking left to right. Follow this graph and keep going down and left. Where is it going to start? inputs change directions, the domain is the same. The domain will always be the same. But our range, however, has changed. What's our lowest point? And then what's our highest? 0. So it changed our range. In set builder notation, that would be y such that y is less than 0. Go ahead and put that in your calculator. Tell me what that is. What? -2.23. And we're running from here 10 minutes, so it's -2.2. That works. Alright, we're going to skip to this is 6, number 8. Now we've changed our a value again, and we're going to see how that affects it. So same as before, take our 1/4, raise it to the negative square, so we can base flip it, make the exponent positive, then multiply by 3. What would that give us? You need to do it step at a time. What did you say? 48, yes. So this would be 16 times 3. What would 3 times 1/4 to the -1 be? 1/4, take the base, flip it, raise it to the power of +1, multiply it by 3.
3/4.
Say that again.
3/4.
Not quite. So 1/4 to the -1 would be what? Sorry. 12. The whole thing's going to be 12. Because this would be 4 times 3. Right? 3 times 1/4 to the 0. 4. Not 4, but close. Not 1 either. 3. This would be 1, and then we're multiplying by 3. And then 3 times 1/4 to the first. Once you figure out the pattern, you could start using that pattern instead of using your calculator. Say that one more time. It's going to be over 4. So each time we're doing what? What's that pattern? Divided by 4. So divide by 4, divide by 4. If I divide this by 4, I get a fraction. If I divide this by 4, that would be the same as multiplying by a 4, which would be 3/16. Go ahead and graph those points. I'm going to draw in the -1 to the 12. What's our y-intercept? 0, 3. Ariana, what's our domain? to, what's our range here? Go ahead and put 3 times 1/4 to the 0.5 in the calculator, figure out what that is. Tell me what that is. 1.5. Right, we're going to skip to number 10. So now we've changed the a value and it's negative. So same process, do 9 to the negative second. They flip it, make the exponent positive, and then multiply by negative 3. And we'll say that you'll get a fraction, and you may need to simplify. What would this part be? 9 to the negative second. That's would be the final answer, yes. So this would be 1 over 81 times negative 3. It would be negative 3 over 81. And then you could simplify that. So negative 1 over 27. So figure out what negative 3 times 9 to the negative 1 is. Again, you'll get a fraction. It'll need to be simplified. So that one more time. Negative 1/3. Negative 3 to the 9 times 0. Not 0. Negative 3. 9 to the 0 would be 1 times the negative 3. Negative 3 times 9 to the first.
Negative
7. And negative 3 times 9 squared. It's a really big number. What would that give us? Negative 3 times 9 squared.
Negative 2.
So really you can only just graph the first 3, but that's okay. One more, what's our y-intercept here? 0, negative 3. Brian, what's the domain? lowest point, think about our highest point. Okay, go ahead and put this into your calculator. Russell, tell me what this is. Negative. Right. Go on to, we're going to skip to 15, and then we'll do one more, and then we'll be done for today. A general rule, whatever your A value is, that's going to be part of your y-intercept. So in this one, we don't have x's, we're not given x's, but we know we want to include the y-intercept. So we're going to put 0 in for x, put it in the middle, and then fill out the rest, -1, -2, 1, 2. So this is always a good place to start. If you want to add in more after that, you're welcome to do so. And then you can do one of two things, one of three things. You can put these into x and figure out what each one is by hand or in the calculator, or you could go into the table. So I'm going to graph this. Go into the table, second graph. Okay. I forgot I had to change this. And then I can just write in those 5 points. If I had put, I'll do that in a second. Negative, or 3.06, 5, if I had put each value in, -2, 4 to the -2 would be 1/16 plus 3, which would give me that. 4 to the -1 would be 1/4 plus 3, which would give me that. 4 to the 0 would be 1 plus 3, which is 4. 4 to the first is 4 plus 3, which is 7. And 4 squared is 16 plus 3, which is 9. So you can do it by hand, you can do it in a calculator, or do it in a table. So let's go ahead and graph those points to the best of your ability. I'm just going to say 2 negative, so we're way up there. What's the y-intercept of this one? You know it, you can say that one. 4. The domain hasn't changed, so still negative infinity to positive infinity. But our range is different. What's our lowest value here? Did this go past 3 to get to 2? Will it go past 3 to get to 2?
3.0.
So, is this the lowest? It's just the lowest we have in the table, but is it the absolute lowest? It's not going to go past, it's not going to go all the way down here. These are getting really, really close to what number? 3. So that's where that will start. So anytime you add or subtract something at the end, it's going to change where your range starts, depending on anything else that they have. Okay. Last one, number 16, is a combination of a bunch of different things. So again, let's put 0 in the middle, fill out our table. Go ahead and put that into your calculator and find your y values. and tell me what your y values are. Isaiah, do you have the y values? Put them in your calculator. Put this into your calculator. Is that right? What's the next one? Brianna, do you have your y values? So I'm put that in the calculator. Jade, do you have the next y value? Make sure you're putting that in the calculator with business. And the rest of these y values, what are they? Next one. Next is 1. And then my next is 2. If I were to graph these points, the first, 3 kind of look about the same place. But then you start to see a little bit of the curve. So if you wanted to get more points, you could just graph that. I'll put this really quickly. If you wanted more points, I could go forwards, do 3, 0, 4, 4, and 5, 12. You don't have to graph those points, but you can if you want. I already forgot. 4, 4. So then you could see more of the curve. Again, you don't need to do that. You could just kind of guesstimate where it is. But if you wanted to be more accurate, then you could do that. And that's what the y-intercept became. Negative 3.5. 0, negative 3.5. Jaden, what would that domain be? Negative infinity to infinity. Our range, what's our lowest point? Our lowest y value? Negative 4. These are getting closer and closer to negative 4. Plus. And it goes to infinity. The very last question, bless you, is a challenge question. It's asking if you can find the equation of the exponentials. Try to, if you want, the hint to you I'll give is look for what's happening between the y values, and that might be a good starting place. So in about 10 minutes, I'll let you put up your calculators and grab your phone, so you can work more in this. On the Dust Math, let's do this Friday, which is the characteristics of quadratics, the characteristics of exponential functions, or you can work on things. So be working on one of those.